three graphs drawn up here. And what I want y'all to think about and try to describe for me, I'm going to put an f of c up here. And f of c is going to be between f of a and f of b. In the first two cases, we see that f of b is greater than f of a, but in the last occasion, we see that f of a is greater than f of b. So now, based on that, and f of c is this y value right here, and I'm going to draw a dotted line through it. What I want you to do is tell me how I can get from f of a as a function. So, it's, you think about the vertical line test, it would have to pass that, which means that each domain has only one range value. How do I get from f of a to f of b without touching f of c?
Having a limit.
What now?
Breaking continuity.
All right, well, give me an example.
Like having a hole where f of c is.
So having a hole where f of c is. So I'm going to be a little bit extra with this drawing. So there we are. In fact, we went up above f of b, didn't we? But each time I hit f of c, I have an open circle there. So limits exist there, right? Limits exist there, but I never hit f of c. Can y'all think of another way I could possibly get from f of a to f of b without touching f of c? All right, well, this is a removable discontinuity, right? What if we did this? What if I started here and I said, okay, I'm going to go down right here, and then all of a sudden I'm going to come up from here, and that's going from f of a to f of b without touching f of c, right? Anything else?
Could you do where it's like a jump one?
A jump, okay, so I could go from here to, I don't know, let's say here, and then come down and be here to here. And that would be going from f of a to f of b without crossing f of c. So, based on those three things, they have one thing in common, and you mentioned it right from the beginning. You mentioned it quicker than what I wanted you to, but that's fine. If you see it, you see it. So what do those three things have in common? Discontinuities. The only way we were going to be able to get from f of a to f of b without crossing f of c was to have a discontinuity in there. Now, I say that I could have a discontinuity in there and still cross f of c. So I could have done something like this. And it's discontinuous at a point it crosses f of c. But the only way I'm guaranteed to have a value that crosses f of c is if that function is continuous throughout that range. So this is called the intermediate value theorem. And we're going to write this down. The intermediate value theorem. And I may state it different from what your packet states it, but the intermediate value theorem says that if f is a function that is continuous on a closed interval from a to b, and again, a to b is a range value. I'm sorry, is a domain value. Those are domain values. You're going from a to b. You're going left to right. You go a to b. So we've got f is a function that is continuous from a to b. Then there must exist at least one c value that is in the open interval from a to b. In other words, it can't be those endpoints. Must exist at least one there must exist at least one c value in that open interval from a to b for every f of c. No, I should say that. Let me reword that. For every range value between f of a and f of b. And then f of a and f of b not included. So when I say between f of a and f of b, I don't mean f of b and f of a are part of that interval. They cannot be included. So, like I said, let's see. If we get there, I mean, let me look at this one, for example. Here's your f of a and f of b. And we'll go, I'll even drop down here first. And I'll almost get there. Okay, now I'm going to get there. So, there's just no way to get from here to here in a continuous function. And again, that's the main thing. We're continuous in an open interval from a to b. So yes.
So why is the second one not continuous? Because we already have that with the
This is a vertical asymptote.
Yeah, the vertical asymptote. Actually, no, that makes sense.
Oh, you got it? Okay.
Yeah.
That's the reason I hesitated answering that question, because I figured it was going to
Yeah.
come to you what was happening there.
Yeah.
All right. Any other question here? All right. So that is what we're looking at as far as the intermediate value theorem. Now, your calculator uses the principles of the intermediate value theorem to solve for a zero. And we'll look at how to solve for a zero in your calculator in just a second. But essentially what you're going to do is you're going to type in a function. And that function is going to say, hey, there's a zero value right there. So what your calculator does is your calculator says, hey, I know this function that we just entered into the y equals screen is continuous on a closed interval from a to b. And what you start doing is you pick an x value to the right of the intersection point and an x value to the left of the intersection point. And then what you do is you push enter, and after that it zeroes in on them. So what it's doing is it's taking these values between where you go from positive to negative, because it knows the whole time if you're going from positive to negative that there's got to be a zero in there, and it narrows in on it and finds that value. So that's the principle behind finding the zero in your calculator. Like I said, we'll look at that in just a second. So let's take, again, from your packet, on continuity. Let's go to the last page of your packet there, and we're going to look at this problem that is the square root of x to the fourth plus 25x cubed.
What question is this?
60, I think, plus 10 equals 5. Now, it wants us to verify that there is a value in there that you could plug in for x and be at 5, and we're going to be between 0 and 1. All right, so for the intermediate value theorem to apply here, two things have to happen. The first thing that has to happen is we have to know that we're dealing with a continuous function. Well, this function right here, it's defined from 0 to 1, essentially, because if you plug in 0, you get a positive number. You plug in 1, you get a positive number. So anyway, we're going to be continuous on that interval. So it checks the first box. F is continuous on the closed interval from 0 to 1. Now, the second thing we want to look at here in order to verify that the intermediate value theorem applies for this is not quite as blatantly written as continuous on the closed interval, but it's in there. What we have to show next is that this value here of 5 is between f of 0 and f of 1. Okay? So, what is f of 0?
0.
It's the square root of 10, right? F of 0 is the square root of 10. And then what is f of 1? Well, it's 1 plus 25, which is
22
and 26 plus 10,
is
36. And what is the square root of 36? 6. So, does the intermediate value theorem apply here? Yes. So, f is continuous, and f of 0 is less than, now we don't need a less than or equals here because that would not work. But f of 0 is less than 5, which is less than f of 1. Or, since we've already solved these values out, you could also say the square root of 10 is less than 5, which is less than 6. That would probably be better, but unless you've shown this right here, you can't just jump to that. Are we okay? All right. So we know the intermediate value theorem applies here. Now we're going to look at solving it. So what I'm going to do is I'm going to solve for a 0 on my calculator. But the way I'm going to do that is I'm going to take this original equation here, which is x to the fourth plus 25x cubed plus 10, and I'm going to subtract 5 from that, and I'm going to show that it's equal to 0. So in your calculator, type in that equation. And again, when we solve this answer out, what does our answer need to be between?
0 and 1.
Yeah, 0 and 1. When we solve for this x value, it needs to be between 0 and 1. Not between the square root of 10 and 6, but between 0 and 1. So you go to your y equals screen and type this in. you go to the graph. Are y'all getting a good graph here? Trying to remember what this graph looks like. Okay, that's not right, because that is definitely not crossing between 0 and 1. So, no, it's plus 25 x cubed.
Oh.
You pulled a Coach Moret there by changing signs in the middle of a problem.
Okay.
All right, so is it crossing between 0 and 1 there?
I don't think so.
Yeah, it is. Let me see what yours looks like. All right, so that's good. So here we are, and there's 1 and there's 0. Now, what you want to do next is you want to go to second and above trace. There's the calculate button. So second trace, and it's going to ask you for a left bound.
Do you want us to click on 0?
Well, you can. It doesn't matter. You can put 0 in there because it would work. So, but you can tap left and right, or you can just go ahead and put 0 in and push enter if you wanted to do that. Now, if you notice when you have 0 in there, you've got a negative y value. Do y'all see that? It tells you what your x is, and then it should show a negative y value associated with it. Are you getting that?
Can you look at my?
Yeah.
I'm not quite sure.
Yes. So that's your negative. Y says it's negative 1.8 whatever. Okay.
So why is x then?
Well, that's 0.
Oh.
8 times 10 to the negative 9. That's 0. That's 0.0. So that's 0.
Yeah.
All right. Are you good? Okay. So now let's scroll to the right. Don't scroll up, down. Scroll left, right with your arrows, and scroll over until you find an x value that gives you a positive y value. Got one?
Yeah.
Okay. Now once you get there, push enter. And then your calculator will probably say something about guess. Don't do that. Just push enter again. And what does it give you as that x value?
It asked me for a right bound after that.
Oh, you didn't find the... Did you scroll to the right till you had a positive y value?
Yeah.
Did you push
wait,
enter?
the left value is okay. Hold up.
Yeah, your left value should be this negative one.
Okay, I got it.
So you may have to start back over. If you never pushed enter when you were at 0, then you need to start it back over. That's the reason we practice this in class. Because a lot of times my instructions are not the clearest, as clear as they could be.
I got an error.
You got an error?
Yeah.
Okay. So go ahead and just close out that screen, and then go back to second trace and do your 0. Now scroll. All right, just push enter. You don't have to be at 0. You can be just anything that gives you a negative y value.
Oh, okay.
All right. Now did you push enter?
Yeah.
Now it's asking for a right bound. So go. Do you have a positive y value yet? Okay. Now you do. So push enter, and then push enter again. All right. Did you get a value?
My y value is 0.
Yeah, that's right. So what are we getting as the x value? 0.8.
3, 4.
Let's go 4 decimal places. 4.
8, 3, 4, 2.
Okay. And what do we know about 8.84? It's between 0 and 1, right? So that is our particular C value. The homework from this section right here is going to be, in addition to that problem you just did, I want you to do 59, 61, and 63. 59, 61, and 63.